certain. I want to use it opportunity to, go through what somebody left in the comment section. So I want to look at this question. I believe if the person is there, he or she will also pay attention and get the full explanation of what it's all about. So in electrolysis, when we believe that we have a Faraday, 1 Faraday for each 1 mole, for 1 mole of electron, 1 mole of electron, that for a univalent, that is element that has one electron, that always lose one electron. Let me go by that. So those ones, they need what? 1 Faraday. 1 mole. To deposit 1 mole of the electron, it will require equal to 1 Faraday. Example of such is what? Silver nitrate. Silver will require what? 1 electron to give us 1 silver metal. So there's other ones. The other ones, something like copper. Copper is 2 divalent, meaning that it will need what? 2 electrons to give us copper metal, for copper metal to be deposited. Something like aluminium will take what? 3, will always liberate 3 electrons, release 3 electrons. Will do what? Will require 3 E, that is 3 E now, to give us aluminium metal. In other words, in that case, one mole of each of the electron will require what? 3 Faraday. For this, for aluminium is 3 Faraday, for copper 2 Faraday, for silver is what? 1 Faraday. This is depending on the number of electrons they always release, as in give out. So that means it's in the number of electrons that will make it up. So in that case, let's just go back to some questions. I have 2 questions that I want to look at, so that to help us to get this thing down. I know the person should be here, and I think I can still remember the name. The name is the channel handle is at Faraday. I don't know if I'm pronouncing it well. Fred at Fred. So if you are actually here, I will leave this thing at that very comment you made, so that I believe it will help you to really understand, because the major purpose of this channel is to make sure that you gain what you want. We want to add value to students that really want to learn. So some students that are really fighting so hard to make sure they make it. So we are here. Major reason we are doing here is just to make sure that such students will be what? A success. So let's look at the first one here. Say how many Faradays of electricity are required to deposit 0.2 mole of nickel if 0.1 Faraday of electricity deposited 2.98 grams of nickel during electrolysis of its aqueous solution. Now, the relative molecular mass of nickel is what? 59. Now, what are we doing? Like what we have already stated earlier on. The first thing we do, we find out that this one is what? This one is in grams, and we have the first statement in moles. For us to actually get this thing done, we need to know what we have in moles. So we need to convert this one to moles. We need to convert it. If we are to convert it to moles, what are we going to do? What we are going to do in this case is that we are going to be, since we have the relative molecular mass, which is almost the same thing as molar mass. So what we do to convert that to moles, to convert 0.98 grams to moles, what we do here is that 2.98, I say 0, divided by what? 58. That will give us so that will give us, what we divide is 2.98 divided by 959. we'll have what we have here will be 0.0505, yeah, moles. That is what we have. Now, based on the thing we have already established that, we just did based on the number of Faraday, based on the number of Faraday. Now, we have this to be what? The Faraday here is, this is 0.1. So, 1 mole, 0.2 moles. We have now 0.2 moles of nickel require what? 0.1 Faraday F. Let's use that. Let's go like that. So now what are we going to do? We need to find what this one will be. What will this one be? That means 0.0505 mole will then be 0.1 over 0.2 times 0.0505 over 1. So let's see what we get there. Times 0.1 divided by 0.2. So what we have is 0.02, let's say 253 Faraday. I think that's how many Faradays. That is what we should have here. That is just what we have. This the way of solving it. So I believe that this thing is making it a bit clearer. So what I have here is that I compare the ratio. After comparing the relationship, since 0.1 mole will give us it, then we need to find out what we have here. By so then we're able to arrive at this. So when we have, remember this Faraday, you can also, if you multiply by the Faraday, you get the quantity of electricity. That means F, the Faraday is always a Coulomb. So when you multiply it, you get the actual thing, but then we can leave it like this for now. So I believe that this thing is making sense. So let's go back to the very question where you asked the question. You said that in the question, the video is the video that has this very question I'm going to solve now. I want to repeat it here. Now the question said a current of 5 amp, was passed through copper sulfates for 1 hour using copper electrolyte. Calculate the mass in gram of copper deposited. We have relative molecular mass of copper to be what? 64 and 1 Faraday. We have it also there. So, and we know what 1 Faraday means. So now let's quickly rush into that, what we have there. So in this case, look at what we have. We are given the number at the time, the current, we have the hour. Now the hour will normally work in seconds. The time is always in seconds. So now everything is given to us. We have the relative atomic mass, and then we have the Faraday there. So in order to calculate what we want, in order to find this thing, the mass deposited, now we look at it in the Faraday mass relationship. Now we look at it that way. So we talk about the mass. If the mass, we know that in copper, we require what? 2 electrons to deposit what? Copper metal. So since then, what it simply means is that if it's 2 electrons that it requires, it means that it will be what? 2 Faraday instead of 1. So that means for us to deposit 1 copper, for us to deposit 64 grams of what? Copper will be equal to what? 2 Faraday. So from here, we know that for copper to be deposited, it will need what? 2 electrons to give us copper metal. So in that case, remember what we have already established, that for 2 divalent electrons, metals or elements, they will need what? 2 Faraday. So in that case now, what we need are 2 of these Faraday will deposit copper. Now this 2 Faraday is the same thing as, since we know the relative molecular mass of copper, which is this. That is what it will deposit. So now the next thing we are going to do is to get the quantity of electricity we have here, and we know that the quantity is always equal to over time, current over time. Our time is always in seconds. So if in that case we have current times time, which is 1 hour, that means 60 times 60. That will give us I think it should be 4 times, let me use calculator please so I won't make mistake. What's wrong with this calculator? 60 times 60, that will give us, then multiply by 4 times 4. We have 1444 coulomb. This is coulomb. The unit is always coulomb. So that is what we have. So now what it means now is that for this quantity of electricity, for us to what are we going to get from what 14400 coulomb, because this other one is also in coulomb. What are we going to get from here? We don't know this one. We don't know it. So if we don't know it, what else are we going to do? Now, if you convert for every Faraday is equal to 96500. Will give us what? 64, sorry. So now 144400 coulomb will that be equal to 6 over times 9 times 14400. I think is correct now. Over 1. So let's see what we get here. Times divide by 9 divide by 2. So we have approximately grams. We have it 4.8 grams. So that's what we have here. But I want to be solving it in another method. We're going to be using another method to solve it. That is formula method. We're going to be using formula method. In the formula method, look at how we do it. This is the mass. This is the molar mass. And then this is the what? Current. This is the current. And this should be the time. And this other one should be the charge. And this is the Faraday. Faraday charge, current. Current, time, mass. The mass we are looking for. This is the molar mass. Relative atomic mass is what will be here. So what do we have here? The mass is the one we are looking for. This one is known, which is 64. And then current is known to be what? 4. And the time should be in seconds. That means 60 times 60 all over charge, which is 2 times coulomb. 1 Faraday, which is 96500. So this is another way of doing it. If you cross multiply this thing, I think it's going to make sense. We have M equal to let me just go straight. We have it M will be what? 4 times 4 times all over 3, that is 3600 all over 200. So that's what we are. Let's see what we are going to get if we are going to get the same thing by using this formula method. Times 36 divide by 2. So you can see we have the same answer. Grams approximately. So thank you for being part of the class, and remember, so this is where I will be leaving it. If you still have any question, you can leave in the comment section. And even though this question we have here should be in the comment section or the description of the channel. So feel free to ask any question you want. We'll be here also to attend to you. If you are joining us for the first time, make sure you subscribe, and then like and share. So any question you have, see, leave it there. We will always attend to you. Now I want to thank you for your comments. That is I don't know if I'm pronouncing it very well, the name very well. That is by Fred for your question at by Fred. By Fred. So thank you for the question, and I hope you stay with us.